Oh, pardon me. Hey guys, hope everybody's doing well. I'm a little winded, as you can tell, but yeah, I'm glad to be here. We're talking about regression today. So for the last couple of months, we've been talking about hypothesis testing, and we're still going to be using what we learned in hypothesis testing, and a lot of the stuff we're talking about depends very heavily on those on the insights from hypothesis testing. Um, but one of the frustrating things about okay. So this is the way in which it's the same as hypothesis testing. Before I move on, let me back up. So what we were interested in before was population, the population, and in particular population parameters, right? Population parameters, they're descriptors, right? Characteristics of the population, and we care about them, right? We care about the population because the population is the way the world works. Right? And we care about the way the world works because, well, for whatever reason you care about anything. If you're motivated by profit, knowing how the population works can make it more profitable. If you just like understanding about the population is understanding the way the world works. Whatever you're interested in, knowing about the population is of interest to you, right? Because we're talking about the life of batteries if you're in the battery industry, or we're talking about consumers' likelihood of buying your product, or how much college is going to cost when it's time for you to pay for college. Maybe right now, maybe again sometime in the future. Understanding population parameters tells us interesting and important things. The problem with hypothesis testing is that for a while we've been using very little data. So hypothesis testing, it essentially uses one dimension, right? So if we care about, let's say, like if we care about nurses' salaries, what we looked at was just nurses' salaries, right? So we have a sample of salaries, and that is all. Sample info on salaries, and that's all the data we use, right? That's really important. I mean, it can be useful to look at that information, and we're certainly going to need that information now. But the only thing we really looked at, was we might compare between two samples, and so if we can show that they differ between one sample and another sample, or for some observable reason, and that can be useful, right? Now, in practice, we often have a lot more data, right? So let's say we have people, nurses' salaries, right? Nurses are people, and we might know a lot more information about those people, right? We might know their education. We might know their location, right? What city they live in. We might know their their scores, their test scores, so some measure of ability of some kind. Um, Lots of stuff, right? We might know their employer, right? And if we know their employer, we might know things about their employer, right? The size of the employer, and other compensation, right? Maybe the employer has a really fantastic healthcare program, and if we know that, then we might know, well, the reason their salary is lower is because they're being compensated in another dimension. In any case, uh, we might care about the way in which two characteristics for an individual are related, right? So we have info on salaries. One of the most common questions people like to ask is, well, how does education affect salaries, right? Do you earn more money? And does education affect salaries differently across different places, right? So if you get an education in a city, there might be more employment opportunities, which means that you might have more opportunities to take advantage of that education. On the other hand, if you get an education in a rural area, maybe your job is the only good fit for you in that area, and so because there's a thinner market, maybe there's a differential effect of education on salary, depending on where you are. This kind of information is really essential. The relationship between two or more variables, right? I mean, this is key, right? Is one thing correlated with something else? And this relationship between two or more variables is used a lot, a whole lot. We've briefly touched on it when we did two sample comparisons, but we're really going to start taking a powerful approach. This powerful approach that we're going to use to analyze this kind of stuff is called regression analysis. So we call it regression because the first people who started to develop these techniques in the 19th century were looking at height. They were looking at and they noticed the tendency of strange occurrences to be followed by less strange occurrences. So if you had an extremely tall parent, their kids would tend to be shorter. If you had an extremely short parent, their kids would tend to be taller. And that's why, and that phenomenon is called regression to the mean. And so, this was the first example of what we might call the analysis of a stochastic relationship. And that's what we're really looking here. We're looking at stochastic relationships. Stochastic is often described as the opposite of deterministic. And a deterministic relationship means X directly leads to Y with certainty every time. But much as we were taking advantage of with respect to hypothesis testing, what we're doing now is, well, X leads to Y with some randomness. And that's a stochastic relationship, right? So there's something going on. We can see it in general on average, right? On average, this relationship is there, but it's not so direct as a deterministic relationship. Deterministic would be, classic physics type relationships on a macro scale where, you fire a projectile and it travels a certain distance every time. Whereas this stochastic relationship has to do with, random variation that happens. Okay, so that's the basic concept. We're looking at these stochastic relationships. So what do we use it for? Well, we use it for a few things. One, we use regression to quantify, to identify, and quantify relationships between two variables, which I'll just call right now multivariate relationships. And we're talking stochastic relationships here. It says relationships. My handwriting is slowly getting better, I swear. Two, we're going to test theories about how two things are related. Two or more, but about how two variables are related. We might look at how strong a relationship is. So we want to know not only are things related, but how strong is that relationship. And we're going to use something called the coefficient of determination to look at that. And then another, and a very important for us reason is to, it's called R squared, sorry. Another and very important relationship or use of regression is to make predictions and analyze variables. So predict one variable. Predict one variable based on another. So for example, if you want to do cost estimation, you might take all the things you know about a product and relationships that you've identified historically, and then use that information, build a model, and then use that model to predict what is likely to happen in the future. All right, I'm just going to change colors just for the heck of it. So let's see. There we go. Okay, so before we move any further into getting into the nitty-gritty of how to do regression, I'd like to just get some vocab down. Okay, there's a bunch of stuff we're going to need to understand. We're going to be building relationships between variables, and we're going to be making these formal. The way that we're going to do this is we're going to be looking always at well, for now at least, we're doing simple linear regression. We're going to be looking at two variables. In every case, even when we get to more than two variables, we're always going to have one dependent variable, and this is the variable we're trying to explain or predict. Some other names, usually we denote it y, and some other names for it might be the variable of interest, or the left-hand side variable, left-hand side variable. Oops. Some people will abbreviate that as LHS, so I'll write that here for you. And then on the other side, on the right-hand side of what's going to be our model, we're going to have independent variables. Independent variables can come in all sorts of varieties. We'll look at a few. Usually we're going to be using continuous or at least numerical variables. These are usually called the x's. Simple linear regression just has one x. We'll get there, but independent variables. These come by other names. They're often called explanatory variables, which I like. They're called explanatory variables because we're using them to explain variation in y. They're also called regressors sometimes. So if you ever see that, they're talking about the s's because you regress y on the x's. So those are the regressors. Okay, so we have one dependent variable. We have one or more independent variables. And in addition to the variables, we have parameters. So these parameters quantify the true relationship, just like before. They quantify the true relationship in the population. And what we're going to be doing is we're going to be developing a model of a relationship, and then we're going to be trying to make inferences about those parameters. Now, much like before, like every parameter we've dealt with, and if you're forgetting, the parameters are the stuff that we've dealt with before that were Greek letters, right? So before, for hypothesis testing, we looked at the mean, the standard deviation, the variance, right? Those are the parameters we were looking at before. We also looked at the population proportion. And so those were all the parameters. We're going to be using Greek letters for the parameters still. The problem is that we can't identify and observe this true relationship. We can't identify and observe the parameters. So this was the insight for which we used hypothesis testing before, and all the statistical inference we've done, including confidence intervals and point estimates. So what we are going to do now, just like before, is we're going to take advantage of sampling theory. And we're going to take samples, and then we're going to use estimators to estimate the value of the parameters. So estimators are formulas that generate estimates. They use sample data to estimate the parameters. This hurts my hand. I apologize. That's why it's part of why my handwriting is so terribly vile on this thing. Okay, so we're going to be estimating parameters like so. Much of the time, what we're going to be looking for is a correlation. So that's a lot of what we'll be doing is dealing with correlations. So let me just write correlation down so you can see how that word is spelled. I'm going to be talking about it a lot, but a correlation is a relationship between two population characteristics. Okay, now in simple linear regression, what we have, and these characteristics are not the parameters, but the variables that we're looking at. So, okay, so in simple linear regression, what's the basic idea? Well, what we're hypothesizing is that there's some linear relationship between two variables. By linear, I mean it's shaped more or less like a straight line. Between two variables. These are going to be y, which is a dependent variable, and x. Okay, so for example, what might this relationship look like? Well, it might be, or what might some of these variables be? Well, we might care about, hold on one second. We might care about, as I said already, salary and education. We might care about, say, a change in sales and how a change in sales affects a CEO's compensation or the composition. That's what I'm going to look at in my example today. Or we might care about, what else? Anything really, right? how price affects quantity demanded. If you're estimating demand, how the length of a book affects its unit cost. If you're a book publisher, whatever you're interested in, I'm sure anytime one thing has an effect on something else, or two things are related, right? How much nutrition your kid gets, and how that affects the amount of sleep he gets at night, or what his grades are like in school. Anytime we have these variables like this that we want to look at, we can use a model to try to analyze this, and we can use regression to try to get at what's really going on. All right, so I'm going to stop it there. I'll come back and we'll look at how a change in sales might be affected, or might be affected by the composition of a CEO's compensation.